March 1980. Thank you. I'm consenting to being recorded. Yes, I am. There we go. So the Great Aurora Substorm of 13th of March 1989 really piqued my interest. I was working for Astronomy Now then. Patrick and I had started Astronomy Now with Peter Catamoni and Nicholson, and we got a huge number of reports in for that Aurora Substorm, and it was really very interesting. It was about the same time that I made my first journey overseas. I did a couple of trips to Alaska in that time, in the period between 1988 and 1990, and then I didn't go up to Alaska again until 1998, and I went three times: 98, 99, and 2001. And obviously, those days you were recording aurora on film, a 36 exposure roll of Fujichrome. But I spent most of my time not taking pictures at all. I spent most of my time in those early trips just watching. I would just go out, I'd stand or walk around and wait for it to start, and I'd watch what happened. And I spent lots and lots of time not taking any pictures at all, just watching how the displays developed. And it helped me to try and understand how the aurora changes, the clues when it's about to do something, the clues when it isn't. And that set me in good stead for when I started to go more often to initially to Iceland and then to Norway, northern Norway, Sweden, and Finland. So this is really the story of 25 years of aurora tracing, and it began um, in Alaska, as I've said. You can see this is a Defense Meteorological Satellite image of the North Polar region. You can see Greenland in the center there. Alaska is over towards the top left. Can you see my cursor moving? Yeah. So Alaska over here, and here we've got the auroral ring, obviously very active over Scandinavia here. This is Iceland, and you can see the ribbons of auroral light encircling the magnetic North Pole. So from Britain, obviously, the nearest places to travel to get into the auroral zone, as we call it, are Iceland here and the northern parts of Norway, Sweden, and Finland. Alaska over here, a lot further away, but obviously very, very cold then. I went, most of the times I went to Alaska in those early days, in the late 80s and the late 90s and 2001. I went north of Fairbanks, and I went in March. And at that time, the weather system in Alaska was very stable. You'd have a stable anticyclone would sit over the middle of Alaska. You get unbelievably cold weather. It would be, minus 30 to minus 40 at night, and that's without wind chill. But you'd have clear night after clear night after clear night. And if you picked a time around new moon from last quarter to first quarter, you could probably guarantee to get, maybe 10 clear nights in that period. So it was a really, really good thing to do. Unfortunately, the climate over Alaska has changed. And I've been to Alaska a few times in the last 20 years. And again, I've gone at the same times as when I went before, and it's never been quite as good. So for ease of travel, Iceland and the northern parts of Scandinavia are much better. So I began by going to Iceland because it was quite convenient to go there, quite easy to fly there. And so my first forays, aurora observing and trying to image the aurora and to try and understand what was going on, were all in Iceland. And here's another DMSP image of Iceland to the bottom here. And you've got this lovely auroral structure here over Greenland there. Now, most people who go to Iceland obviously go fly to Reykjavik, and most of them stay there. I decided right early on that I wasn't going to do that, because although you can, of course, see the Northern Lights from Reykjavik. It's on the southwest corner of Iceland, and a lot of the prevailing weather comes from this direction. In addition, Reykjavik is a fairly brightly lit city, and unless you travel some way out of Reykjavik to the north of the city, where you've got dark skies to the north of you, it's not an ideal location. And I was struck when I first went there that most of the tours that you could sign up to go aurora watching, most of the ones that were available, would sort of take you out in the mid-evening, and they come back at midnight. And I didn't want to come back at midnight. I wanted to stay out all night. And of course, if you're up there in the middle of winter, your nights can be very long indeed. So I decided fairly early on that what I would do is I'd fly into Reykjavik. I'd then fly up to Akureyri, which is up in the north here, and I'd travel across to the northeastern corner of Iceland, where it is very dark. The weather can be quite cold and stable, and you've got an incredibly good view out to the north directly towards the auroral ring. And so most of my Iceland aurora observing has been done from this area in northeast Ireland, between Húsavík and the Lake Mývatn area. Now, when I started imaging the aurora with my early digital camera, which was an old Canon EOS 450D to start with, I didn't have a very wide angle lens. I had a 28mm lens equivalent on full frame, and this is one of the images that I took. And yes, it's okay. It shows auroral structures, and the stars are nice points, obviously. But I was annoyed that the fact that most of the aurora structures I wanted to see wouldn't fit on the camera. You know, it was always something happening outside the field of view. So this is one example. There's another example. Here's a nice aurora structure directly overhead. You've got Cassiopeia over on the right here, and quite a lot of auroral structures. But again, there were lots of things going on out of the frame. Here's a lovely structure overhead. You've got Auriga here, and the Pleiades, and Perseus, bowl of the Big Dipper over on the left there, and quite a nice structure. But again, it sort of annoyed me that I really couldn't get everything in. So I invested in a fisheye lens. And most of my pictures from then on were taken with the fisheye lens, and you can instantly see the difference. Yes, you get a curved horizon. You've got the plough there above left to centre, but you could start to get an idea of the grandeur and the majesty of the whole thing. And that was what I was interested in. I wanted to capture that. The other thing that I was quickly learned was the fact that when you're taking pictures of the Northern Lights from land and you're set up on a tripod, the tendency often is to lower the ISO, in some cases to maybe 400, 800 ISO, and to increase the exposure time to 20, 30 seconds. In fact, I've seen many aurora photographers advocate using really long exposures like that to really bring out the color. But I found that there was something that I was missing if you did that. And that was fine structure. The one thing I always wanted to try and record and understand was how the fine structure developed and changed over time. And so I started to experiment with increasing the ISO and dropping the exposure time so that I could record much finer structures without the movement of the aurora display blurring the fine detail. Now, in some cases where you've got an auroral display going on, there's always a certain amount of movement and the detail isn't quite the way you want it. Here you can see a nice structure high up, and you've got fainter diffuse aurora behind. And again, I was still trying to perfect the method of this balance between ISO, noise, image noise, and the length of exposure to get the detail. I also met a lot of like-minded people. On my many trips to Iceland, I met a lot of fantastic people who were fascinated by the aurora. And here's a group of people that I photographed watching a display, in late at night, and we'd often stay out all night until dawn broke. One of my trips in January to Iceland, during the height of the quadrantid meteor shower, just so happened while I was taking this shot, I call this my little house on the prairie shot. You've got a very faint display. It's nothing great happening, but a nice bright quadrantid fireball just happens to go through the field of view while I was taking the shot, which is quite nice. This, at last, I began to get it right, where I could freeze the action, as it were. Because with a short exposure of just a few seconds, yes, you need to increase the ISO, and it's often a balance between the brightest parts here, which are just almost burned out, but keeping the exposure short enough to record these very fine auroral structures. And so this was something that I was learning all the time. So I learned a lot about the balance between exposure time, ISO, field of view, and how to keep your camera warm in very cold temperatures, particularly if it was windy, and also how to keep myself warm and comfortable if I was outside for many, many hours trying to record what I was seeing. Surprises were always an element. On one evening, I wasn't even dressed in my gear, but I'd gone outside and it wasn't even properly dark. It was still twilight. And to my utter astonishment, I went outside, and in bright twilight, there was this amazing auroral structure, of which you can see here, because I didn't have the wide angle lens on at the time. You can see the Seven Sisters up in the top left there. And I stood, having seen that this developing, I rushed back to my room. I was still in an ordinary shirt and trousers. I had no cold weather gear on at all. And I got the camera out, tripod out, set it up, got some pictures. And this was the first time that I saw something that I'd been led to believe up to then was extremely rare. I know it's not rare now, but at the time, it was the first time I'd seen it, about 20 years ago. It was in March, and it was the lilac-y pink color of nitrogen molecule emission between 95 and 100 kilometers above the ground. And the green emission, I'll talk more about the colors in a moment, but the green emission above is oxygen emission between about 100 kilometers and about 150 kilometers above the ground, oxygen atoms. And when you get a very intense display, the energetic particles are coming down into the atmosphere and they penetrate below the 100 kilometer level, and they excite nitrogen molecules between 95 and 100 kilometers. And I read about this lilac-y pink, and I could see it forming, and I was actually amazed, but I was even more amazed with what happened then. That color is no exaggeration. That's exactly as the camera recorded it. It's not you can see the head of Draco here. You can see the top of Cygnus there, the swan, and you can see the color. And this lilac-y pink was only visible for about 5 minutes before it faded away. But it really was utterly striking. And it was one of the most vivid colors at the time I'd ever seen. So the early trips to Iceland taught me a great deal about being prepared for the unexpected. This is a structure that I saw in the early hours of the morning. I called it Thor's Hammer. And I was always trying to photograph interesting structures. And this was something just formed up. It was only visible for 10, 15 seconds, and then it went. And it's obviously an extreme fisheye view because that's the lens I had on the camera at the time. Sometimes you don't have time to prepare, but you get something interesting like this. And I also started at that time with my first forays into time-lapse. And this was a time-lapse sequence put together as a movie. So lots and lots of still images. And this is speeded up by a factor of 10. So in other words, what you're seeing here is happening 10 times quicker than it was happening in real life. But I decided that I wanted to try and get some movement and try and show people the incredible variety and structures that form and change, and to try and make it more interesting for people. So this was again the first time in those early Iceland trips that I experimented with time lapse, and this is one of the early experiments that I did. Here are some of the different auroral structures that I saw in those early days. Often a glow, just a brightening of the sky towards the north, no discernible structure. An arc, usually grey-green or greyish bow, stretching roughly east to west, sometimes single, multiple, double, usually uniform in brightness. A band, a ribbon-like structure that snaked back and forth across the sky. And I would often see bright spots forming on the bottom of an arc or on the bottom of one of these bands. And if the band or the arc had been fairly uniform, and then these bright spots started to appear, that would often indicate that vertical bundles of rays were going to appear along the arc or band, making a rayed arc or band. And then curtains or draperies, when the rayed arc or band, the rays stretched up to near the overhead point higher in the sky from our location. When you get the aurora forming all around you, and the rays go up towards the zenith, then you have the possibility of the formation of one of the most spectacular auroral forms, which is the corona or crown. And these are really quite amazing. Sometimes you can go a long time seeing lots of aurorae, but you don't see a corona. And then during a really active display, you might see a couple. And in the biggest displays of all, you can get many coronae through the night, forming up, dissipating, the display dying down. So during some of the greatest displays, you get many coronae, and you can see all of these forms of auroral structure as well. So I'm going to take you through some of these different structures, and also how an auroral display develops and builds. But many of my recent trips to observe the aurora have not been to Iceland. They have been to northern Norway, Sweden and Finland. And after a couple of trips to northern Norway, I started to work with Hurtigruten, Norwegian Coastal Voyages as it was. They used to run a ship every day from Bergen in the south of Norway, right up round North Cape to Kirkenes on the Russian border. And every day a ship would leave going north, and every day a ship would leave coming south. And so you could join the ship and sail all the way up into the Arctic Circle, round to Kirkenes and come back again. And this gave you 6 or 7 nights within the auroral zone. And it was a really good place, I found, to base oneself for aurora viewing. But of course, as I quickly found out, taking pictures from a moving ship is a very different kettle of fish to taking them from the ground, from a place like Iceland or somewhere on terra firma. Observing the northern lights from ships is nothing new. Here's a painting by Frederick Church of the 1865 aurora in the Smithsonian American Art Museum, showing a lovely display and a ship there in the foreground. The ship that I was going to go on was a little bit more modern than that. This is one of the ships I've travelled on, one of the Hurtigruten fleet. This is the Trollfjord, one of the two biggest ships in the fleet. There were 3 big ships: the Trollfjord, the Midnatt Sol, and the Finnmarken. Trollfjord and Midnatt Sol were sister ships, and the Finnmarken was a slightly different design, but they were all around 16,000 tons gross tonnage. And here the ship is sitting in Kirkenes harbour at the turnaround point, and you can see the landscape, very snowy, very icy, and can be quite cold in Kirkenes in the middle of winter, -20 or below, and that's without wind chill. So this was to be the base, if you like, where I would carry out my next phase of Northern Lights viewing. I had many beautiful clear nights, dark skies, using the fisheye lens from the front of the ship. You can see I'm getting about 140-degree field of view, and on a nice clear night like this, one would hope that something was going to happen fairly soon. Now, most displays will begin with a green homogeneous arc in the north. I say green because that is indeed the colour it is, but to the naked eye, the colour will not be apparent when the display is this faint. One of the things that people don't fully understand until they get there is they expect to immediately go out and see the colours that you see in all the pictures. This is not the case. Our eyes are not designed to see colour when the light level is low. When the light level is low, we can see quite faint structures, but we won't see colour. So when you look at a green homogeneous arc like this forming in the northern sky early in the evening, it will just appear greyish, or maybe grey with a hint of green, but it's only in the camera that the colour will be really obvious. In order to see colour with the naked eye, you need the display to be much more vibrant, more active, and that will often happen later, or it may not happen at all. These quiescent homogeneous arcs are the way many displays begin. But you don't necessarily know whether that's all you're going to get, or whether the display will turn into something else. Now, there are two questions that I always get when traveling with groups to see the Northern Lights. Three questions actually. The first question, which you get in the afternoon, are we going to see Northern Lights tonight? Well, all you can say is that the weather looks as though it's going to be clear and we're in with a good chance. The second question is, what time are they going to appear? As though you have some huge electrical switch that you throw and bang, there they are, this wonderful cosmic light show. So you have to say, well, they could appear as soon as it's getting dark, they might not appear till midnight, or they might not appear at all. And then the third question you get, when there's a display already there, and it might be one of these quiescent homogeneous arcs, the question has two parts. The first part is it going to do anything soon, or is that it? And the other part of the question is, I'm desperate to go in for a pee. Is it safe to go in now, or is something likely to happen while I go in? And the one thing I've discovered is this. You can be watching one of these quiescent homogeneous arcs for several hours, and it won't do anything. It potters about, it changes, you get the odd brightening, the odd ray popping up here and there, but nothing really to write home about. And after a few hours, you're getting a bit fed up. You want to go in and warm up, have a cup of coffee, go and have a pee. And you can do that, but that will be the signal for the aurora to suddenly burst into life. And you can go inside for 15, 20 minutes, and you'll come out again. And when you come out, it'll look exactly the same as it did when you went in. And you won't be aware that anything has happened at all. But don't worry, all those people who stayed out and saw a great display are only too willing to tell you what a great show you missed. So it's quite hard sometimes to learn whether a quiescent homogeneous arc like this that's been sitting there for a long time is going to do something or not. But there are clues. One of the clues is that you get these bright spots appearing along the bottom of the arc, and they may brighten, they may start moving, and rays may start popping up. Another thing that can happen is that the arc can become double or triple or multiple, and that the arc you've been watching, which might be the middle one, a new one forms above, or a new one forms below, or you might get one forming a long way higher in the sky. And when you get rapid development of arcs like this, it's not a good time to go in and have a pee, because that's a sign something is or could be about to happen. Because very often when you get these brightenings, you can see some bright blobs along the arc here. You can see some rays popping up. Now, there's a ray here from an arc that's below the horizon, but we're too far south to see that. But these arcs are obviously at different distances from us. Now, the bottom of a green arc like this, as I've said already, is about 100 kilometers altitude in the atmosphere. So basically, when you see arcs like this one is the nearest one to you, that one's a bit further away, and that one's further still. And you can see arcs when they are 1,000 kilometers to the north of you. So you can see structures when you're a long, long way south of them. And this is the other thing. What you see not only depends on what's going on, but your relative location to where the display is taking place. So, for example, here, when we're many hundreds of kilometers south of where those three arcs are located, we're seeing them broadside on. But someone who might be 500 kilometers further north would have maybe the nearer of these arcs overhead, and they would have a completely different view to the one we're having here. Now, this particular three arcs had been sitting there for about 15 minutes. There were odd rays popping up, and then if you look towards the northwestern end, which is over here, you'll see that kink developing. And that kink and a ripple from here happened quite quickly. And a few moments later, in this region here, this is what happened. So this is the northwestern end of that homogeneous arc. You can see the arc there, descent going below the bowl of the plough there. And you can see this lovely, gentle structure. This again is speeded up 10 times. And the ship is moving quite a bit. So there's a little bit of changing aspect there. But you can see an idea of the lovely, delicate structures that occur. And you'll see that it's quite early on. It's still bright twilight in the northwestern sky. And one thing I've noticed, if you see a fairly faint display against a backdrop of a bright twilight sky, it's easier for the naked eye to see the colour than when the sky is a lot darker. And that's because the brightness of the twilight is triggering the colour sensors in your retina, and you can see the blue and the sort of pinkiness along the horizon, but you can also see the colour in the auroral display. And then later on in the evening, when the sky is really dark, you'll get a similar auroral display, but you won't see the colour because your eyes are more dark adapted and the colour sensors are not being triggered because the display isn't bright enough. The twilight is helping you see the colour in the aurora by triggering the colour sensors and getting them off the ground, so to speak. So this is the sort of structure that can develop quite early in the evening. And this is often when many people who, in the guidebooks, it says the aurora appears about 9 o'clock in the evening. No, it can appear any time. In the middle of winter, when twilight goes on for a long time at high latitudes, in fact, it can go on all day, I've seen the aurora at 3 o'clock in the afternoon. And I've seen it at 8:30 the following morning. So this was a display around about 6 o'clock in the evening, quite early on, and then it faded. So here we have a rayed band. So this is the second structure. We've got the arcs, I've just shown you those, and you get this ribbon-like structure snaking across the sky, and you'll see mainly green, but with just a faint hint of red above. Now, the particles that are causing the aurora emission, of course, are coming down from space, following the Earth's magnetic field lines, and are colliding with oxygen atoms between 100 and 150 kilometers above the ground, and exciting them produce a green light. Higher up, the oxygen atoms are being excited to produce a lower energy red emission between about 150 and 250 kilometers above the ground. And that faint red emission is quite hard to record with the camera unless you use longer exposures. But because I'm on the ship, I'm having to keep my exposures very short. The longest exposure I will tend to use is about 2.5 seconds, and I'm using 3200 ISO. So the red is often tricky to record from the moving ship, easier to record from a land-based location because you can extend the exposure and you can bring out the red better. With the naked eye, red is a hard color to see really vividly because our eyes are 5 times less sensitive to red than they are to green, and this means that it's quite hard sometimes to see the red with the naked eye. I have seen unbelievably vivid red displays, particularly from Alaska, but that's just because it's been an incredibly vivid, low energy oxygen emission. And if you don't have the bright green below, it's often easier to see the red above because the green can drown out the red because it's a lot fainter. So that's a rayed band. Now, these structures can move in a quite dynamic and exciting way and be like ribbons dancing in the sky. If you imagine a dance troupe where they've got those wide ribbons as they dance across the stage, they're twirling the ribbons around their heads, that's very often what these types of auroral display can appear like. So this is another movie. This again is speeded up 10 times, and it's on the very furthest north of the Hurtigruten trip. This is about just over latitude 71 degrees north, and on the northern part between North Cape and Kirkenes. And you can see the plough over to the right there. Quite a lot of ship movement because it's a fairly bumpy part of the sea, and I've got a movie there showing you how one of these ribbons of light comes out from the northwest, snakes around in the sky. Now this is a similar part of the trip, different voyage, and this is quite a broad ribbon of light, quite bright, moving across the sky. You'll see some lovely S-shaped structures moving along it. But the ship is sailing into a band of thick cloud. I am standing at the back. The cloud I can see is all in front of me, and the ship is sailing into the cloud, and the cloud bank is beginning to come over, and you can see the detail is now much muted. However, this display is so bright that it will actually shine through cloud. And I've seen many auroral displays shining through cloud. The cloud is illuminated green, takes on the color of the moving auroral display behind. And these ribbons of light in the Arctic sky are really quite lovely to see. And as long as there's not too much cloud, the cloud can often add foreground interest to what's going on behind. But when you get thick cloud, it mutes the detail, you can't see the fine structures, and all you'll see is moving color strips behind. Now, this was a really quite remarkable display. This is what I described as the genie coming out the bottle. Originally, there was just this faint green band here, and then this brightening appeared, climbing in the sky and swirling, and it really did look like a genie coming out of a bottle. And at the same time, all of this other structure appeared around it. The whole thing developed from nothing to something in under a couple of minutes. So if you'd have popped indoors just for a cup of coffee, you'd have missed this incredible thing developing. I didn't get a movie. It was only a still frame, but it shows the incredible variety, the brightness, and also the speed with which these structures can form. So we talked a bit about the red. This is a rayed band where you've got the nice band of green across the sky, a nice clear starry night, and you've got the lovely rippling structure in the green, and the red is slightly washed out, slightly overshadowed by the green below, but you can see that there is the lower energy oxygen emission above. So the green there between 100 and 150 kilometers, and the red between 150 and 250. Sometimes the red is more obvious. This is a case in point. This is north of Lofoten, and you can see there the constellation of Leo, nicely placed in the middle there. Is the twins of Gemini there. And what you've got is you've got quite a bright green rayed arc here. And then the green fades, and because the green has faded, the red is more obvious. And you've got these lovely red rays and the green, and they're going up quite high into the sky, meeting almost overhead. And when I saw this and I saw the rays growing upwards, I realized that there was a chance of a corona, where the rays all come to the magnetic zenith, the magnetic overhead point, not the actual overhead point, but the magnetic zenith, and the rays come together, and you get this amazing multi-pointed structure. And there it is. This was one of the most interesting coronae I'd seen, because it was centered right on the plough or Big Dipper. So you can see there the bowl of the plough, the hand of the plough, and you can see the green all around, the green rays and the red. Now, I'm looking up through the display. Imagine like a funnel. The green is around the bottom of the funnel, and the red is above it at higher altitude in the atmosphere. So I'm looking right up through the auroral display. The rays are actually all parallel. It's an effect of perspective that they appear to radiate out from the magnetic zenith, which is there. It's just the same as when you see a meteor shower. The meteors appear to radiate out from a single small area of the sky that we call the radiant of the meteor shower. All the meteors are on pretty much parallel paths. It's perspective that makes them appear to radiate out from one part of the sky. In this case, the electrically charged particles are coming down into the atmosphere, striking the atoms of oxygen higher up, giving the red, lower down, giving the green, and producing this multi-pointed effect. Now, coronae can take on many, many different forms, and I will show you some more in a moment. So this is a curtain or drape with the green and now a different color, purple or violet. There are two main gases in the Earth's atmosphere, oxygen that we've mentioned and nitrogen. Now, whereas oxygen atoms are fairly easy to get excited by colliding them with cosmic particles in the upper atmosphere, nitrogen atoms are much harder to get excited. You've either got to whack them really hard, or you've got to soften them up with ultraviolet light beforehand. And so around the time of the equinoxes, end of September, early October, end of March, early April, you will find the upper atmosphere is bathed in ultraviolet light all night, and the nitrogen atoms are then easier to get excited, and they give out a beautiful violet or sometimes a deep blue light. I've seen both colors at different times. I've even seen them both together. Here we've got a lovely great drape of green. You've got the violet higher up. The violet color will often be between 200 and even 400 kilometers above the ground, higher up than the green and the red of oxygen emission. This is dawn. This is nearly 3 o'clock in the morning. The light of dawn at the bottom there. Got some tropospheric cloud in silhouette. And there you've got a lovely rayed arc there, needle thin like rays going up. And again, the backwash of violet nitrogen atom emission. So the blue, the violet, the turquoise blue you sometimes get is all due to high altitude nitrogen. But I've already mentioned that spectacular lilac pink. In the most active displays, where the energetic particles are penetrating below the 100 kilometer level, they excite nitrogen molecules between 95 and 100 kilometers, and this was an example of such an emission. This violet, clearly visible with the naked eye, it was visible for about 20 seconds, and this was one of the pictures that I took to record it. So those are the main auroral colors, but you need the display to be vivid, vibrant, and active to see those colors with the human eye. The camera will always pick them up easily, and you can see that here. Now, the earliest record that we can date of a Northern Lights display is the 12th, 13th of March, 567 BC. It's from Babylon, modern day Baghdad in Iraq. And you might be thinking, that's a long way from the Arctic Circle. And you'd be right. But remember, the auroral oval is centered on the magnetic North Pole. And as the magnetic North Pole wanders across the Earth's surface, which it does, the auroral ring centered on the magnetic North Pole will shift. And it just so happens that 2,500 years ago, the magnetic North Pole was a lot further east and a lot further south than it is today. And this meant that it was possible to see aurorae from northern Iraq. And this clay tablet of an account of the aurora borealis is the earliest dated record. There are a number of Chinese accounts and Korean accounts of the aurora borealis as well, around 2,500, 2,600 years ago. But the scientific investigation of the Northern Lights began when the polar explorers first started going towards the North Pole in the latter part of the 19th century, and then, of course, to the South Pole, when they realized that there was an analog to the aurora borealis around the South Magnetic Pole, the aurora australis, or Southern Lights. Now, I have only ever seen the Southern Lights from an aircraft flying from southern Australia and from southern Argentina, but I've never actually seen them from the ground or from a ship. But certainly the scientific study of the Northern Lights and eventually the Southern Lights began with these polar expeditions. The Norwegian explorer Fridtjof Nansen was quite an accomplished artist, and here we can see a lovely frontispiece from one of his books of an auroral display that he saw. Scientific understanding of the Northern Lights is really down to this man, the Norwegian scientist Birkeland. Now, Birkeland was a brilliant physicist, engineer, inventor, and Birkeland was fascinated by the Northern Lights. He is the gentleman on the left wearing the fez. For some reason, he always wore a fez when carrying out his experiments. Don't ask me why. But this is an experiment he set up in his laboratory, where he set up a large glass chamber, evacuated it to very low pressure, and he put inside a metal sphere, which he magnetized, and he then fired electrically charged particles at it to create an artificial aurora. And here we can see the rings of auroral light around the metal sphere being created in Birkeland's laboratory. Now, Birkeland was way ahead of his time. He had shown that the Northern Lights were an atmospheric phenomenon. He tried to measure the height of the auroral arcs, found it very difficult to do, but certainly realized that they were high in the atmosphere, although he didn't realize how high. And he was asked what was happening, and he said, this is a phenomenon caused when electrically charged particles from space are coming down into the Earth's atmosphere and colliding with the particles of air and making them glow, producing this light. And of course, he was absolutely right. But he was then asked, where do you think these electrically charged particles are coming from? And he said, "I think they're coming from the sun." He was laughed at. In fact, he was treated disgracefully by the scientific community at the time. The Royal Society in London were particularly unpleasant to him. He was only able to publish his papers in the Compte Rendu from the French Academy of Sciences, who were rather more broad-minded than the Royal Society. Berkelland would die relatively young. We don't know if he committed suicide or if he died of natural causes. He wasn't a very healthy man, but he was also a somewhat unhappy man in his middle age. But he died tragically young, and he never lived to see his prediction come true. It would be nearly 60 years after Berkelland said that he believed the particles came from the sun that the first satellites launched into orbit round the Earth discovered the solar wind, a steady stream of electrically charged particles and gas flowing outwards from the sun. True that Berkelland was so far ahead of his time. The sun, of course, is the source of enormous amounts of radiation, neutral gas, and plasma. Gas which has been split into protons and electrons, and those electrically charged particles stream out from the sun in all directions as the solar wind, traveling at varying velocities from about 200 kilometers per second to, in some cases, nearly 2,000 kilometers per second. Spacecraft in recent times have enabled us to understand and view the sun as never before. We can see here a movie taken by the Solar Heliospheric Observatory back in 2002, showing the sun slowly rotating. It's in ultraviolet light, but it shows you the enormous energy and the activity of the sun. You can see explosions occurring, plumes of gas rising above the sun, being shot out from the sun, some rather gently, some more violently. And this gives us an idea of the enormous variety of solar activity that is causing variations in the solar wind. We see the solar wind, of course, during a total eclipse of the sun. Here is the total eclipse of March 2006 from near Jalo Oasis in Libya, taken by Tony Morris, a really quite wonderful view of totality. And you can see those beautiful, delicate streamers of the sun's outer atmosphere, the corona, the polar brushes, top and bottom. And you can see how the corona is sculpted by the solar wind flowing out into space. If we create an artificial eclipse using a coronagraph and make a time lapse, we can see how those coronal streamers are changing over time. Time is obviously speeding very rapidly here, but we can see the enormous variations in those coronal streamers and the variations that will cause in the solar wind. There will be increases and decreases in the solar wind, and there'll be sudden impulsive changes of velocity due to eruptions in the corona. Now the sun is on the left here. We see the solar wind flowing out from the sun, carrying with it its embedded magnetic field. And the sun itself is embedded in a magnetic bottle, the magnetosphere. We're a bit like the Starship Enterprise with the shields up. The magnetosphere is protecting us from the majority of the electrically charged particles coming our way. The solar wind is diverted around the Earth's magnetosphere. But downstream in the magnetotail, particles from the solar wind are able to cross over into the Earth's magnetic environment and are accelerated down towards the north and south magnetic poles, where they spiral down the field lines, causing auroral displays. Now, it's not just eruptions on the sun that can cause variations in the solar wind. Some of these eruptions on the sun will be associated with sunspots. Some will not be associated with sunspots at all. Some will be associated with twists in the sun's magnetic field at the solar surface, and they will lead to variations in the solar wind velocity. But when the sun isn't so active, for the years around solar minimum, you get quite a lot of these. Now, what you're looking at the bottom there is a coronal hole. It's an enormous rip in the sun's outer atmosphere, the corona. And through coronal holes, the sun's magnetic field lines are open to space, whereas, as you can see elsewhere, the sun's magnetic field lines are tangled, and it's harder for particles to get out, unless there's an eruption of some kind. But through these coronal holes, magnetic field lines being open allow particles to flow out at high velocity into interplanetary space. And so coronal holes can bathe the Earth in high-speed streams of solar wind for many days at a time. And I've seen some really quite superb displays of aurora generated by the solar wind. So here we've got the sun, we've got the solar wind streaming out from the sun there, particles heading out from the sun at varying speeds. We're going to pull back from the sun now, and a couple of sunspots there. Here's the Earth surrounded by its magnetic field in blue. The particles from the sun in yellow are wrapping themselves around the Earth's magnetic field, are pressurizing the Earth's magnetic field and squeezing the Earth's magnetosphere. If you look at the right-hand side, the field lines are being squeezed together. Particles cross over and are accelerated towards the north and south magnetic poles, producing glowing rings of light. The aurora borealis around the Arctic, the aurora australis around the Antarctic. Well, there's a view looking down on the aurora australis, the southern lights. You see around the Antarctic continent there is very few people who live under that ring, and it's not a place that tourists will generally go. You can of course see the southern lights from Tasmania, southern parts of Australia, South Island, New Zealand, southern parts of Argentina and Chile, and less often from southern parts of South Africa. But in the main, you're viewing them at a distance because they're always going to be viewed over the Southern Ocean at great distance from you. It's quite different in the Arctic, because in the Arctic, the normal position of the auroral ring, seen in orange here, this is an old view from the Dynamics Explorer satellite, you can see the aurora ring passes over northern Alaska, northern Canada, Hudson Bay, southern tip of Greenland, northern Iceland, and the far north of Norway, Sweden, and Finland, and Siberia. So from the British Isles, you can travel to northern Scandinavia, to Iceland, or even Canada or northern Alaska to see the northern lights. You can do that in the middle of winter. You can station yourself right under the normal position of the auroral ring, which means you can be ready for auroral viewing, something you can't really do in the southern hemisphere. Now, really big solar flares are associated with very active sunspot pairs. Here's a very large sunspot pair. This is the Bastille Day eruption, 14th of July 2000, seen from SOHO. This is the coronagraph image, and you can see with the sun there with the white circle, an enormous eruption, particles being shot out from the sun at nearly 2,000 kilometers per second, covering the space between the sun and the Earth in just between 24 and 28 hours. And it gives rise to a major auroral display. Now, these really big eruptions can cause some of the most spectacular of auroral substorms. The 13th of March 1989 that I mentioned was one of the biggest of the last century, but we know there were others. And in the 13th of March 1989, this is the a time lapse of the activity. You can see the ring, very active, yellow, orange, and red. And in a moment, you'll see a really big red patch appearing over Quebec province in Canada, which blacked out Quebec province for several hours. So we learned that these solar storms can have an impact. They can interfere with satellite communications. They can knock out satellites, send them into a spin. They can interfere with power systems, electricity supplies, and also with large-scale computer networks. This is one of the reasons why there's so much interest in understanding these great solar storms. Now, this is the sun in January 2012. A line of sunspots across it, not particularly exciting. We were looking at this pair of spots on the left here. They were showing some signs of activity, but it was a spot over on the right that surprised us all because it gave out an ultraviolet flare and a coronal mass ejection. And we didn't really think that this CME was going to hit the Earth about 28 hours later, but it did. And I was on a ship heading out of Tromsø northwards at the time, and we had a whole night of auroral viewing. Bands of green and red and purple. This is obviously looking north from the ship as it comes out of Tromsø. And then all night long, a continual display of ribbons of green snaking their way across the sky. The first of many coronae, green around the base, red higher up. There's Cassiopeia in the middle there. A great snake-like, brilliant green coming out of the north, snaking around, twisting, turning, taking on the shape of the Batman symbol for about 15, 20 seconds. Trouble over Gotham City, we thought. And then as quick as it came, it's gone. And this kaleidoscope of movement and color going on for something like 8 hours that night. Many coronae forming, the display dissipating. Here's another corona forming later in the night, that dissipated, and then another corona looking into the trumpet of some exotic flower. So really tremendous display. From the International Space Station, they saw the same thing, but from a slightly different perspective. 400 kilometers above the Atlantic Ocean, looking north, there is a display that I was witnessing from the ground as they saw it from orbit as they circled the Earth at 27,000 kilometers per hour. You can see there the wonderful rays, the structure, the activity recorded by the astronauts in orbit. Now, coronal holes have also generated some spectacular views. Here's a coronal hole at the top there. Again, the magnetic field lines very open to space, particles pouring into space. And when that happens, you can get some very dynamic aurorae over Norway. And you can see here, here's the Lofoten Islands, and this ribbon of light moving north and south over there. If you're underneath it, you can see these wonderful picket fence-like auroral ribbons right overhead. Again, very short exposures. I'm now on the ship taking exposures that are generally a second or less, and many of the exposures I'm taking may be 0.2, 0.3 seconds to try and really freeze the action. And auroral corona, this was seen on a southbound trip coming out of Tromsø heading towards Finnsnes. It looked like a firework cascading downwards, really quite beautiful. There's the plough at the bottom of the view there. And a time-lapse movie taken from Svolvær Harbour. It was absolutely, completely still. And this display went on for over an hour. This is speeded up 5 times. And you can see how this wonderful ribbon of light just changes color and shape and form. A little hint of purple here and there. Here it is a little bit later on that same evening, just wonderful structures changing before their eyes, reflected in the water below. Now, as we left Svolvær Harbour that night, the display had died down. This is a still view I've taken with a different camera, and we're going into an area where the fjord sides are very high. The fjords rise over 1,000 feet at this point. The ship is sailing in a narrow channel between the fjords, and I can see that the display is picking up. There's a certain amount of violet visible, and we're starting to get rays going up towards the zenith, and this corona suddenly appears overhead, and a lot of people are looking at the walls of the fjord. And I'm telling everybody to look up because this incredible formation was only visible for about 20 seconds. This is the first shot. This is the third shot I took, and it's a dragon. If ever there was a dragon, it's as plain as a pikestaff. There's the head, there's the horns, here's the wings, here's the tail. Here the dragon is looking down on me. There it's giving a profile view. The ship is slowly turning, which is why the star trails are small arcs, and this is the dragon over the Trollfjord. I've seen many spectacular coronae formations. This is one of the most. This is a real-time time-lapse movie. This is 0.2-second exposures replayed 5 frames a second. So in other words, it's happening exactly at the speed at which I was seeing it. It was an unbelievably still night. You can see how sharp the stars are, even in a 0.2-second exposure. And you can see how the display, there we are, this incredible coronal structure moving around the magnetic zenith. And one frame from that was my favorite, and I called it the Bird of Paradise Aurora. And it's just so beautiful. The violet of the nitrogen emission and the green of the oxygen. And not everything you see is a real aurora. This is an artificial aurora generated by rockets launched from the Andoya Range in northern Norway. I happen to see the rockets go up. It releases electrically charged ions into the ionosphere. They dissipate over time, and they use this to study the winds in the ionosphere. So an artificial aurora seen from the ship. Quite beautiful to watch, even though it wasn't a real one. But some of them are just beyond description. This is my last slide, and it is like a tiered or layered skirt with these amazing structures, the water, the light reflected in the water. It is just so beautiful. No picture can ever do it justice. And even though I do take a lot of pictures, I never stop watching. I'm never looking through the viewfinder. I line up the camera roughly and I'm watching what's going on while I'm pressing the shutter. And out of 100 pictures I take, there might be 5 that are any good. I throw the rest away. But I have seen what's going on. I've taken it in, and that is the most important thing. A quarter of a century of Northern Lights viewing. There you have it. Thank you. I'll have a drink now.
Well, thanks very much, John. That was, and some of those images were spectacular, particularly the crowns, and really well worth seeing. If people have got questions, if they can electronically raise their hand, that would be helpful and useful.
Are you going to tell me what the questions are, George? Or are people going to say and be heard? Can I hear them?
They'll be audible if people raise their hands.
Look it up. I'm here to be shot at.
I'm not seeing any. Oh, Pauline. Alan.
John.
Yes, Alan.
Why do we get apparently more aurora in the spring March time? Is there another effect going on other than?
It's not just the spring March April time. It's also September October. It's because of the equinox. Because of the equinox, from about mid-March to the first week of April, and from about mid-September to the first week of October, the connection between the sun's magnetic field in the solar wind and the Earth's magnetic field is optimal. It's called the Russell-McFerran effect. And it's why we often get really good aurorae around that time. But I have to say, although I've seen some spectacular aurorae around that time, many of the pictures I've shown you have been taken in November, December, January, February. Yes, you have a good chance of seeing something good around the time of the equinox in the autumn and the spring. It's not that we get more aurorae, it's just that the connection between the sun's magnetic field and the Earth's is more efficient.
We saw one in August out off the coast of Greenland a few years ago. Yeah,
absolutely.
Amazing.
I saw an aurora from the South Downs on the 22nd of June one year.
Wow.
I couldn't see the green or the red. I just saw the purple. I could see the purple at the very top. Obviously, further north, in the north of England and Scotland, they could see more of it. But from the top of the South Downs, I could just see the very top of that auroral display on the 22nd of June.
Wow.
So yeah, you can, if you know what you're looking for and you persevere, you can see these things a lot more than many people think.
John, we've got a question from Malcolm Curry, and
Yes.
he's asking, are space weather forecasts any use to predict whether the aurora will show for your guests?
What a great question. I do not take any notice of space weather forecasts. If I am in the Arctic and I'm in the auroral zone, I will go out from when it gets dark to when it gets light if the sky's clear. And if it's really, really bad weather, I will tune into all the weather forecasts, and there are some really good weather forecasts in the Arctic, and I will check to see whether there's going to be clear sky, and I will look out every half an hour, and as soon as I see the cloud breaking, I will stay out. Very often, auroral forecasts are right. Very often, they're wrong. And the sad thing is, I've seen people look at aurora forecasts which have said, not much chance of seeing something tonight, and they've stayed in bed and they've missed something really good. And there have been people who've seen a good aurora forecast who've stayed up all night have seen very little. Remember, aurora forecasts generally are a global average. What are you going to see on average around the auroral ring? And it may be that you just so happen to not be in the right place at the right time. You know, I've had friends in Canada, I've been in Iceland, I've had friends in Norway and Sweden, and we've kept in contact with our phones and we've WhatsApped us about what's going on. And, you know, one of us can have a lovely display and the others are not. It's a global phenomenon, and aurora forecasts are fine. But if you're in the Arctic, in the right place at the right time, just go out and look. You may be surprised at what you see.
John, I'll use chairman's privilege. Do you often get audible effects around aurora?
I personally have never heard an aurora. However, I have done my best to do so. I have been out in the middle of Alaska, miles from anywhere. I've stood in the middle of a pine forest with a great aurora going on overhead, and I've not heard a crackling or a whooshing. But I've spoken to the Sami people in Lapland. I've spoken to the Inuit in Alaska, and they have told me they have heard the aurora. And I'm not going to disbelieve them because they have spent their entire lives in these places, and I unfortunately can only spend a few weeks there. But I personally have never heard it, but I'm prepared to believe people who have heard a crackling or a whooshing sound. Now, the problem is that that sound must be generated locally. You're not hearing the sound coming from the aurora itself. It must be an electromagnetic effect causing some local phenomenon that is making the sound. But I personally haven't heard it, but I've spoken to many people who have. People who live in these areas, have lived there all their lives, and I'm sure they're right.
Okay, thank you. If people would type questions in, that would help. Because I can't see anybody apart from 1, 2, 3, 5 people.
Right, George, can I ask something then?
Go ahead, Pauline.
John, do you know anything about the phenomenon called a Steve?
Yep.
And have you ever seen one?
Right. Steve, of course, is a flow of very hot plasma in the upper atmosphere. It exhibits itself as a very narrow pinkish or purplish strip that will go across the sky. It often appears in conjunction with what's called a picket fence aurora, which is an aurora with very regimented, even slats across the sky, and Steve can go up. It's often seen at rather lower latitudes than many auroral phenomena. I believe I have seen it a long time ago and not known what it was. I thought it was a ribbon of purplish aurora, not realizing it was in the wrong place. And it was in conjunction with a picket fence aurora, but I have never been able to photograph it. I have photographed some picket fence aurorae, but not seen Steve. I've also seen the so-called sand dune aurora that was in the news earlier this year when it was photographed from Finland. And one thing I have managed to film in time lapse is something that is unbelievable when you see it. And I can't show you the film tonight because it's a film I've been working on through lockdown. It's incredibly challenging, and it's of the so-called flickering aurora. When you've had a really incredible auroral display that's gone on for many hours and the display is dying down, the sky is covered with a wash of very faint green auroral light. And as it fades, it comes on as little patches all over the sky, about a second, and then goes. And it's like being in a disco. You're standing there looking at the sky, and there's a little blob of green appears all over the sky at random. And it goes on for ages. And on one night, I was lucky enough to take pictures for several hours because I had to use a very high ISO. It's very noisy. And I now I'm running it through a denoise program. By the way, people often ask me, it's related to this, what I do with my pictures. The pictures you've seen have not been enhanced in any way. They are as they are out the camera, with one exception. I use a program called Denoise AI and another program called Neat Image, noise reduction programs. If you're shooting at 3200 ISO, even if the exposure is short, you do have noise. And so I run the images through this. And what I will often do is I will often straighten them, because on a ship, the horizon might be a bit wonky. I will often straighten them. And sometimes with some of my fisheye shots, I get rid of the slight curve by applying the distortion algorithm for that particular lens. But I don't change the color. And the reason I don't do it is because I like the pictures that I show people to be not so ridiculously exaggerated that when they see the real thing, they think, oh, that's a disappointment. And that's the other reason I use Canon cameras. The sensor in Canon cameras makes the greens a lot more pastel-y than in Sony, Nikon, and Fuji. Their greens are much more vivid, probably nearer to the actual green emission that oxygen emission is giving out. But again, it's not what the eye sees. I use the Canon camera only because, to me, when I show a picture like you're looking at now, it's much more as I remember it when I was looking at it. Long answer to a short question, but yes, I've never managed to photograph Steve. The Dutch lady I mentioned earlier who's worked on the library, she has. And I'm hoping that I'll photograph it at some stage when I get back to my aurora watching, hopefully this coming autumn, winter. But it is a very interesting thing. But it's not.
Thank you. Thank you, John.
Phenomenon.
Thank you.
High speed stream of thermal plasma in the upper atmosphere.
Got a comment from Malcolm Curry, really in response to the audio issue, and he's put local sound, same as the electrophonic fireballs.
Yeah, he's absolutely right, of course. Yeah, a local effect, creating the sound that you hear locally from the object that's a long way away. Yeah.
Okay, right. Again, if anyone's got a question, could they type it in? because we've got screen share on at the moment, so I can't see anybody's face or
Do you want
anyone
me to, do
waving.
you want me to stop sharing? I'll stop sharing.
Yeah, that will allow me to drop that down. Then I can see if anyone's waving a hand around or not. Oh, just realised we've got 3 screens because we got over 50
Oh, yeah.
people.
55 people there.
Okay, well, I think on that note, can I once again thank Dr. John Mason for an extremely entertaining and very informative talk and some spectacular looking images.
Very good.
Thank you, all of you. I'm glad I was able to join you virtually because I wouldn't have been able to come probably to Newbury on a Friday night. So it's great. And thank you to Anne for asking me.
Thank you so much, John. Thank you. Appreciate it. Brilliant talk as usual. Thank
Thanks,
you.
John.
See you all. Take care, all of you. Hope
Yeah,
to see you
cheers,
in
John. Nice
the
to
Alistair
see
Sea.
you.
Good to
Yeah,
see you,
and
John.
bye all.
Bye.
Take care.
Bye.
Okay, it's 5 to 9. So if we have a, let's say, a 20-minute break, so if we can get back by 9:15, then we'll do the AGM, and it shouldn't take too long, he said, hopefully. So we'll see. But you should all have been sent a copy of the chair's report and the financial statement. So I'll leave the screen running, and obviously you can chat amongst yourselves, or if you are departing, it might be helpful just to turn the camera off.
I'll leave now.
Yeah, okay, understand. Yeah.
Cheers then, George.
I'll
Thanks
leave as
very much
well.
for the invites.
Thanks very much. Really interesting.
Yeah, great evening.
Yeah.
Yeah, likewise.
Yeah, no, I understand. How shall I put it? AGMs are not very exciting.
Is that all that's going to happen? Is there going to be anything else after the AGM, or is it just the AGM?
Unless somebody is got some images or a talk, I was not sent anything. So
Because I'm not a Newbury member, I'm a Reading member. I probably shouldn't really be at the AGM, should I? So
Don't worry, Jane, I'm going to stay because I'm interested in how Newbury are going to handle next year. I mean, discussing with Chris Memure our own attitude. So I'll be intrigued.
well, yeah, obviously you're more than welcome to stay.
Well, I actually made a membership attempt at this year, George, but you said you told me to take the money back, but I didn't. I left it with you.
I was thinking.
Actually, I'm a member. Technically, I didn't sign anything.
I should say I've had a written question and I'll respond to it at the meeting on money as best I can. Right, I'm going to go off and get a drink.
Hang on, George, can I just ask, do we really need 20 minutes? Can we not make it 15?
Oh, what, before we convene?
Yeah, it just seems a long time of sitting around waiting for the AGM.
Okay. All right,
I would second that.
yeah, I'll kick off then. So I'll just give it, we'll go for 10 past.
Thank you.
How are you, Kath? You're looking very well.
Yeah, I'm fine. Thank you, Steve. And you?
Yeah, I'm fine, thank you.
Have you been out into the big wide world recently?
Well, I went on my bike today.
All right.
Yesterday,
Have you been to a supermarket yet?
yes,
Oh, well done.
a couple of weeks ago. So,
Right. Well, I'm waiting to hear from you, along with a lot of others.
well, it was all right.
I'm not sorry, I'm not talking about that. I'm talking about a summer gathering.
Oh, yeah. I didn't realise that you actually wanted a reply.
I do want to reply, yes.
Okay, it will be done.
I need to know numbers.
Right. Okay, that's great.
Don't
Did
get your money yet.
Did I send you a few details about the Fashion Family Fun Day? Because I couldn't remember whether you had said you wanted to help or whether I actually sent it to you.
Sorry, Steve, you're talking to me?
Yeah. Yeah.
I won't be going. I've got
that's
another
okay.
event on that weekend.
Okay, that's fine.
Sorry. Always clashes.